In the last video lesson, we talked about how bonds are broken during when particles receive energy, and how bonds are formed again to make new substances or particles. And we also abbreviated how the energy profile is drawn in a very simple manner, where we have reactants and products in straight lines, and it tells us about the state functions, that means the final state of the reactants and the products, but it doesn't really tell us anything in between, because we talked about how energy is absorbed into the bonds, and when energy is absorbed, the bonds are broken in an endothermic process, and then when bonds are reformed again, energy is released in an exothermic process. Now, these processes are what it says, just processes. It's not really what we define as an endothermic or exothermic reaction. So don't get confused about that. So this old energy profile here does not really tell us anything about what is happening to the energy that is introduced into those bonds and those energy that is released when the bonds are formed. So we need to make a new energy profile. And this is exactly what we have right here. This new energy profile kind of explains what is happening during a reaction. All right? So you have reactants here on the left side. And these reactants have substances with bonds that are like happy. And when you introduce new energy into it, right, in the form of heat or light, and these bonds will start absorbing all this energy until it reaches its maximum level. And what will happen is that when energy is absorbed into it, it will break because there's too much excess energy. This is why you have an upward curve during the chemical change. So all this here is happening during the chemical change. So here, in this path, your bond is being broken. Bond breaks, okay? And when the bonds are reformed to make new substances, right here, during bond form, when you form new bonds, energy is released, all right? So when energy is released, when bonds are formed, energy is released. So it makes products. Now, depending on where the final, where the product is, whether it's down here or up here, that will determine whether that reaction is an exothermic or an endothermic reaction as a whole, okay? So that's what it is. So for every for every successful chemical reaction to happen, what those bonds need to do in order to break and reform is to overcome a minimum energy barrier. And this minimum energy barrier is called the activation energy. And the activation energy is simply from the top of this curve to where the line or where the reactant line is, okay? So activation energy is the minimum energy required for a reaction to occur. So if during a collision, the collision and energy that's been introduced is not hard enough, it may not overcome this energy barrier. So what will happen is that you get collisions that are unsuccessful to form new products, okay? But if you introduce enough energy to break up those bonds, form new substances, that means that the energy that has been absorbed is good enough to break the bonds, to overcome this activation energy barrier, to form new products. All right? So there we go. Again, the y-axis is the energy level, the x-axis is the course of the reaction, and you have your energy level at the reactant side and the product side, and in the middle you have your activation energy. So let's focus down here for a little bit, and you will see different energy profiles. Here you have your reactants and your products. As you can see, the products is higher than the reactants. So overall, this is an exothermic reaction with a medium activation energy barrier. All right? Here you have endothermic because it's higher. I'm sorry, endothermic. Here you have an exothermic reaction because the energy level of the products is lower than the energy level of the reactants. And this energy barrier here, the activation energy, is like a medium size. Here we have reactors really, really low, that have really, really low activation energy level, and the products with a really, really high energy level. And so the activation energy here is really high because it goes from here all the way down here. So let me draw this activation energy for the rest. So you have an activation here, and you have your activation energy here. Okay, all these are activation energies. So this one here is an endothermic reaction with a very high or huge activation energy. Here we have an endothermic reaction because the reactant energy level is up here and the product energy level is down here. So this is a very spontaneous reaction because there's a very small energy, activation energy, right? And it has excess energy that has been released during the new bond formation. And here we have a hypothetical reaction that is neither exothermic nor endothermic, but again, we need activation energy. So here we have one method of examining exothermic and endothermic reactions by looking at the energy profile. There is another method that you are interested in, which is to examine if a reaction is exothermic or endothermic by looking at the enthalpy change numbers for those bonds. And we should cover that in next lesson or in class.